Given a linear equation, we can find the equation of a line that passes through a given point and is parallel to the original line, or a line that passes through another point and is perpendicular to the original line. And so we'll talk a little bit about the fact that parallel lines have the same slope. So the original slope is equal to the slope of the parallel line. Perpendicular lines, their slopes are opposite reciprocals of each other. That relationship is defined in this way. The slope of the original line multiplied by the slope of a line perpendicular to it is equal to -1. If we were to solve that equation for the slope of the perpendicular line, we would divide by the original slope. So we would have the slope of the perpendicular line is equal to -1 over the original slope, or the opposite reciprocal of the original slope. So given this line, y equals 1/2 x minus 4, we can, using this information and this information, determine the equation of the line that is parallel to this one, but passes through this point, and the equation of the line that is perpendicular to the original and passes through that same point, 6, -1. So let's do that real quick. First of all, the original slope is equal to 1/2. Y equals mx plus b. The m of the original line is 1/2. So that means that the slope of the parallel line will also be 1/2. So we are going to use that slope value. We're going to use this point that we were given as our x1, y1 in this formula. Y minus y1 is m times x minus x1. So write the formula. The repetition will help us when it comes time to recite. The y1 value is 1. The slope is the same as the original, 1/2. And then the x1 value is 6. We'll do distribution. And then we will add 1 on both sides. This is the slope-intercept equation of the line that's parallel to this and passes through this point of 6, -1. Notice that the slopes are the same. All right, the y-intercepts are different, and they have to be. If it's the same y-intercept, then it's the same line, and it wouldn't be parallel. It would be the same exact line. So here is the equation of a line that's parallel to this one, but specifically the line that's parallel to this one and passes through that point of 6, 1. For perpendicular, it's a little bit different. Remember, the slopes multiply to give you -1. So, if I know that the original slope times the perpendicular slope is equal to -1, I would say 1/2 times the slope that I'm looking for, the perpendicular slope, is equal to -1. I would solve that equation by dividing both sides by 1/2. Well, dividing by 1/2 is the same as multiplying by 2. So the slope I'm going to use is -2. The slope of the perpendicular line is equal to -2. Now I'm going to use this -2 in this place right here. So it's going to look the same as this does, except I'll have -2 there. Y minus y1 equals m times x minus x1. Plug in my values. Y minus 1 equals -2 times x minus 6. It looks the same, except that this is a different slope now. Instead of 1/2, positive 1/2, it's the opposite reciprocal. So flip it and change the sign. -2 over 1. -2. Distribute. And then add 1 on both sides. This is the equation of the line that is perpendicular to our original line and passes through this point of 6, 1. Y equals -2x plus 13. If we were to graph these lines, these two would be perpendicular to each other, these two would be perpendicular to each other, and these two would be parallel to one another. All right? And you can explore that on your own using your graphic calculator if you prefer.